Hello guys, in this video I'm going to show you how you can come up with a logistic model to help you predict for binary outcomes. For example, if you want to know whether it will rain today or not, or whether someone will play soccer or not. So in this data set, you want to predict whether the mean MPG of a car is below average or above average. So in this case, we have only only two outcomes, which are in a binary form. So when you look at our data frame, there is no attribute which is like a binary attribute. We have MPG, which is in form of numbers. So you have to create. We need to create a variable that contains above average MPG and below average MPG, where above average MPG is represented by a 1 and then below average MPG is represented by a 0. So in this data set, we shall try to create ones and zeros MPG that is categorical. So we shall use in a data frame, we shall create a new variable called MPG category or MPG cat, and it's going to be assigned to, so if else in the data frame we shall look at MPG. So if MPG is less than the average MPG of is less than the average MPG, we shall assign it with a 0, else it will be a 1. So when you run that command and check in the data frame, you will have created a new variable called MPG categorical. So when we try to run our model, we are going to predict for whether a car is below average MPG or above average MPG based on price, rep 78, and foreign. So when we run a model which is from a general linear model, and we are going to first attach this. So let's first attach our data frame df such that we don't have to write df and variable name. So in this case, I'll just write variable name MPG categorical, and it will be predicted by price of a car, then plus 78, repair record 78 plus foreign. Plus foreign. It will be in a family which is a binomial model. So the family of the model shall be binomial, and then run the model. So if you want to look at the summary of the model, it will be simply summary model and then run. So when you try to look at it, it will be well given here, stating the variables that are significant and those that are not significant. When you try to check here, those that have stars are significant because look at the p-values below 0.05. If you want to look at the likelihood ratios of the model, let's first load the library Pacman, and then we shall try to preload test library, and then down here we shall come and write likelihood. It will be our object and assign it to likelihood ratio test. It will be, first of all, when you want to create a likelihood ratio test, you create a baseline model. So this shall be a general linear model. So this one helps us to compare between the model we have and the baseline model to test for the likelihood. So we shall have MPG cut here, and it will be a model like that, and the family shall also be the same as a binomial. So you run it, and in the likelihood ratio test, we put our model, which is we shall put our null model, which is the base model. Yeah, base model, and then we put our model name. So when you run, yeah, we have a base model which we didn't run. So when you run it, and yeah, just had a simple error here in assignment. So when you run your base model and then run the likelihood ratio test and print the likelihood ratio test, yeah, you have the likelihood ratio test right here with a p-value implying that our model is significant. Yeah, thank you for watching, and if this video was helpful, kindly subscribe and like, and also share with friends.